Okay. Online screen visible?
Yes, sir.
So today we are going to discuss about new algorithm, that is Naïve Bayes. That is Naïve Bayes. So this is a new algorithm. It completely works on the Bayes theorem. Will completely works on the Bayes theorem. So Naïve Bayes is used to for the classification purpose. Mostly used for the classification purpose. Okay, classification. Okay. Okay. So navigation is used for the Bayes theorem. They completely works on the navigation. So for example, let me give an example. For example, if you roll a die, what is the probability of getting output? Possibility outputs. So if you roll a die, we have a possibility of 1, 2, 3, 4, 5, 6. These are the possibilities of getting outputs, right? These are the possibility of getting outputs. What is the probability of getting 5 as an output? What is the probability of getting 5 as an output? So total possibilities 6. We have only one chance to get a 5. We have only one chance to get a 5, right? Possibility of get possibility. What is the probability of 5? 1 by 6. 1 by 6. So it is a independent type. It is a independent type. So we have one more method, that is, let us assume this is a box of bag. It's a bag or box container where it contains red balls, black balls. Where it contains 3 red balls and 2 black balls. Okay. What is the probability of getting red ball? 3 by 5. There is 3 balls, right? Total number of balls is 5. So if you remove one red ball, okay, what is the probability of getting black balls? 2 by 4. So because it is depending upon the previous event, independent, like previous event, right? Previous event. So if you apply the independent event, P of red and black equals to P of red and black equals to P of red minus P of red, P of black by red. P of black by red, because it is dependent upon the first event. Because it is depending upon the first event. Because it is depending upon the first event, right? It is depending on the first event. So it is a conditional probability. It is a conditional probability. It is a conditional probability, right? It is a conditional probability. Let me derive one formula from it. So P of A and B equals to P of A into P of B by A. P of A into P of B by A. So we can also write this as, written as P of A and B equals to P of B and A, right? We can also write P of A and B equals to P of B and A. We can also written like this, right? So what is the expansion of P of A and B? This is the expansion of P of A and B, right? P of A into P of B by A. The expansion of P of A and B. So what is the expansion of this? P of B into P of B into P of A by B. Understand? Clear? P of A into P of B by A equals to P of B into P of A by B. P of A by B. So both are same, right? So similarly, they are same. Let me write P of B equals to P of A into P of B by A divided by P of A. One second. A by B equals to P of A. P of B. Simply, I am transporting this into this side. Here the multiplication, it will go the sign means like LHS transformation means it will go for the division. So there is a P of A by B equals to P of A into P of B by A divided by P of B. Understand? P of B. This is known as a Bayes theorem. This is known as a Bayes theorem. This is known as a Bayes theorem. So it is also known as a Naïve Bayes theorem. So completely Naïve Bayes algorithm works on the Bayes theorem. Completely Naïve Bayes algorithm works on the Bayes theorem. So let me give one example. You can clearly understand about it. So example is I have x1, x2, x3, and so on, xn futures. x1, x2, x3, and so on, xn futures, and I have a output as a y. Have a output of a y. Consider it is as a b, okay, or it is considered as a b or a, your wish, a, and completely as independent as a b. Okay, apply the formula. P of a y by a means y by x1 comma x2 comma x3 and so on xn and so on xn equals to P of a means P of y into P of what is that b by a, b by me x1 x2 x3 and so on xn divided by y. Xn divided by whole divided by P of whole divided by P of B. The B, right? Whole divided by P of B. P of B means probability of x1, x2, x3, and so on, xn. Understand how I make the probabilities for this one? Okay, clear? Let me expand this formula. I will make an expansion. Expand about it. P of y into P of y into P of x1 divided by y, x1 divided by y, x1 divided by y. Next, P of x2 divided by y. Next, P of x3 divided by y, and so on. P of xn divided by y. Right? Like this only now we can apply the things. Whole divided by P of x1 into P of x2 into P of x3 into P of x4 into and so on P of xn. P of xn. So this is a formula. Like this is the process of working. Clear? Clear or not? So basically we have two types of things. One is yes and another one is no. Two outputs. So same formula apply for the yes one time. Same formula apply for the no one time. Right? This is a classification problem. So yes or no's we have, or true or false, or pass or fail, like this. So we need to apply once for the yes and we need to apply no for the once. Okay, you will get that. So y is only the independent variable. So first apply the. Let me show you how the problem. First apply for the S. P of S divided by x1, x2, x3 and so on xn. So this is the formula P of y. P of y means formula P of A. What is the A value? P of S. S is known like P of S into P of x1, P of P, x1, x2 and so on xn divided by S. So on divided by S. Whole divided by, it's common for P of x1, x2, x3 and so on xs. Understand? Simply are replacing the value as a S. So y value considered as a S. So because in this outputs we have S, no, right? I consider as a S as a y value. Now same thing I am considering for no. I am considering for the no. P of no divided by x1, x2, x3 and so on xn equals to P of no into P of x1, x2, x3 and so on xn divided by no whole divided by P of x1, x2 and so on xn and so on xn, right? And so on xn. Clear? And so on xn. So understand, see about it. We have done for S and same for no. The denominator is same, right? Fixed denominator. Denominator is fixed. We apply for both. We have a denominator is a fixed. Fixed denominators. We apply the things. We got a fixed denominators. Right? Fixed denominator. So if you apply the values here, for example, if you apply the values, so for the binary classification, P of S divided by Xi equals to 0.13. Just imagine I got it 0.13. Okay. Same like that, P of no divided by Xi equals to I got a 0.05. This is the output. If you apply the algorithm like values. Now right now I didn't take any value. If you apply the values for this algorithm, you will get approximately like this values outputs. P of Y. No problem. So if we apply the value for these things, for this and this, I get a base outputs. Got it? P of X or S by Xi equals to 0.13. P of no Si equals to 0.13. Okay. For applying the normalization, if you want to apply the normalization, so for applying normalization, if in case if you require the normalization, for in case if you want to apply the normalization, simply follow these things. Okay. P of S divided by Xi equals to, I am applying the normalization for the P of S, probability of S I am applying. So 0.13 divided by 0.13 plus 0.05. Understand? This is the normalization for the S. So and so some data we will get as output. So and so data will be getting out. Same like that, I am applying the same for no. For no, 0.0 divided by 0.13 plus 0.05. We get around what's the value? 0.28. Okay, this is a normalization form. This is a normalization form. Understand how exactly algorithm works? It will calculate the base theorem. So it mostly works for the classification purpose. In classification, we only have a true or false or yes or no. So first it apply for the binary like a base theorem for the S and it will go for the no. After that, if you want to apply any normalization like that, we can apply. Clear? Understand how exactly algorithm works? Clear? So now we moving for the practical. Let me move for the practical. Where is the naive Bayes? This is the naive Bayes classifier. Naïve Bayes classifier. Always classifier. So Naïve Bayes classifier, this is the algorithm. So Naïve Bayes classifier is a popular and simple supervised learning algorithm. Use it for the classification task. So if you want to classify anything, we need to use the Naïve Bayes. So why it is called an Naïve Bayes? I have mentioned something here also. You can go through that. So Bayes theorem formula is P of A by B equals to P of A by B into P of A divided by P of C. That is the formula for the Bayes theorem. So here the explanation also presented. So now I am going to implement the things. So import NumPy as NB, import pandas as PD, import MATLAB as .p, pyplot as ELT, and C bond. So warnings, if you want to reduce the warnings, you can simply use this method to remove the warnings. Import warnings, warning dot filter the warnings. Whatever the warnings, if you get like some of the parameters warning, you are not taking this much of parameters, your data is not fit. Like that warnings, simply remove that, ignore. Okay. So I'm taking the adult data set. So data equals to adult date CSV. And let me run. Is there value is presented? No, that is okay. I think so. Data is not presented. Okay. So I'm reading df equals to pd dot read underscore CSV data. So data is the entire part is stored in this data. That's why I call the data. Okay. Now this is the head of a data. This is the shape. There is only 32 rows, 560. 15 columns, 32 rows, 560 rows we have. So this is the head, entire head. So I need to rename the column names because 39 here the state government, then is a number bachelor like that here. So I need to rename the columns with these things. The names as rename, columns as rename. So we can add. So this is basically the age, but the column name is 39. I'm replacing with the age like that. So state government, like it's a workspace. That's why I created a workspace. So I rename the things. Rename ఇలా చేశాను. చేసిన తర్వాత same I'm doing some analysis info. Same if I have a lot of categorical variables here. So I need to convert this categorical variable. Categorical equals to where from the value in a columns. I'm going for the columns. If data set, where is a column name? The column name need to be a categorical. Okay. If the column name need to be categorical, data type equals to object. Exactly where the data type equals to object, we need to gather the data and apply the categorical form. Apply the category. So this is the categorical variables we have in a data. So you can search. So first we get work class. Work class is a categorical. And education is a categorical. Same marital state, everything is a category. Now I need to pass this df dot categorical dot. This is a categorical name, right? This is a categorical names. Now I need to find the is there any missing values in a categorical variable. If there is no missing values, I just leave it there. So now view the frequency count of a values in a category. So mostly frequently occur values in a category, each categorical variable. So in a class private, we have a 22,000. Self-employment, we have 2,000. So local government, we have 2,000. So this question mark is also present. There is 1,539. So this question mark is not that much of important. So that's why we remove this question mark. We remove this question mark. Okay. This is the entire data. So for the removing, like let me find the unique things. This is the unique class labels we have in a work class. Work class, we have some self-employed, private, state government, federal government, local government. This question mark is also present. So we don't require this question mark, right? So just remove the question mark. I am replacing the work class with a NaN values. Okay. That df work class where the column name is work class dot replace question mark with NaN values. np dot NaN. Question mark with NaN values in place equals to true. Question mark with NaN values in place equals to true. Okay, done. Now you can see I don't find any question mark. This is the previous data value count, same value count. I use here I have a question mark. Same after removing the question mark, same I am doing the same visual analysis, but now right now I don't have any question mark. Simply I like I replace the question mark with some other values and values. Okay, same like that. You can apply for the occupation, you can apply for the education, same like that. So here also I found the question mark, simply I am replacing the question mark. So I don't find any question mark. Understand? Simply removing the question mark. We don't necessarily have a question mark. Okay. Now x-axis, y-axis, dependent variables, independent variables. So here the income is a dependent variable for everyone. So here income is a dependence on variable. It's depend upon the class, education, marital status, or say gender or capital, working hours. It depends upon the income is depend upon the remaining columns. So that's why income is a dependent variable and the independent variables are remaining things. That's why x equals to last one. మధ్యలో కూడా ఉంటుంది ఒకసారి మనం డివైడ్ చేస్తాం. ఓకే, సో x equals to df dot draft income axis equals to 1 and where y axis equals to I am taking the income as a dependent. So these are the independent variables, these are the dependent. Apply the train test split. This is the train test split. X train, y train. Now I need to change the categorical variables. So the algorithm can't able to train the categorical variables. So I need to convert this categorical variables into numerical variables. So that's why display the categorical variables first. These are the categorical variables I have, and display the numerical variables I have. This is a numerical variable in the data. In data, after the splitting of x train and y train. So in x train, I found this numerical data, and this is a categorical data. So extend that categorical is null is there. Is there any null values? Mean of null value. So if you find, so this is a print categorical variable with missing data. I am going to print categorical data with missing data. If any categorical variable have a missing data for columns in a categories, for columns in a categories, if x train of column dot is null, which is greater than 0, which is greater than 0, print the columns x train of mean. Print the column x train of mean. So this is a workspace and occupation only. We have a two null values. Workspace and occupation only we have a null values. Import missing value categories. Import missing category value with most figured occur. From df2, this is another variable, x train and y train, and I am filling this entire category. Workspace I have a null values, occupation I have a null values, and one more is there, that is negative country. Negative country is present. Yeah, but it is I think the rare null values is present. That's why it's not showing. So we need to replace with most figured occur value. I am replacing the most. ఇక్కడ ఏం చేశానంటే మనకి ఏదైతే నల్ వాల్యూస్ ఉన్నాయో దానిని మోస్ట్ ఫ్రీక్వెన్స్ అక్కర్ ఏదైతే మోడ్ యూస్ చేస్తాం కదా మోస్ట్ దాంట్లో రీప్లేస్ చేసేస్తున్నాం. సో రీప్లేస్ చేసిన తర్వాత ఈ ఎక్స్ ప్రైమ్ వై ప్రైమ్ కేటగిరికల్ లైక్ ఐఎమ్ ఐడెంటిఫై ఈస్ దేర్ ఎనీ నల్ వాల్యూస్ ఆఫ్టర్ అప్లైయింగ్ ది మోడ్ ఆల్సో. సో రైట్ నౌ ఐ డిడ్ంట్ గెట్ ఎనీథింగ్ ఎక్స్ 0000. సో నౌ ఇప్పుడు మనకి ఏమి నల్ వాల్యూస్ లేవు అంతేనా. సో నల్ వాల్యూస్ లేవు, మళ్ళీ చెక్ చేస్తున్నా అయ్యో మిస్సింగ్ వాల్యూస్ చెక్ చేసా, ఎంటైర్ డేటాలో చెక్ చేసా, దెర్ ఈస్ నో నల్ వాల్యూస్ ప్రెసెంట్ రైట్. ఓకేనా, there is no null values present right. So we need to convert these categorical features into numerics, right? We need to convert these categorical features into numerics. So that's why I'm using the label one-hot encoder. That's why I'm using one-hot encoder. So import categorical encoder dot p. I'm importing the categorical encoder. ఇది మనము మామూలుగా categoricals ని ఎన్కోడ్ చేయడానికి యూజ్ చేస్తాం. చూపించాం కదా జీరోస్ వన్స్ లైక్ కన్వర్ట్ చేయడానికి. సో అలా కన్వర్ట్ చేయడానికి వి యూజ్ దిస్ కేటగిరికల్ ఎన్కోడర్. కేటగిరీస్నే కదా మనం కన్వర్ట్ చేస్తాం, అందులో వన్-హట్ ఎన్కోడింగ్ యూజ్ చేస్తాం. ఎన్కోడర్ ఈక్వల్స్ టు సిఈ అంటే కేటగిరికల్ ఎన్కోడర్ డాట్ వన్-హట్ ఎన్కోడర్. ఏ కాలమ్స్ ఉన్నాయో ఆ కాలమ్స్ అన్ని పాస్ చేస్తాం. అవే కదా మన కాలమ్స్, ఏ కాలమ్స్ ఉన్నాయో ఆ కాలమ్స్ ఓన్లీ కేటగిరికల్ కాలమ్స్ హ్యాస్ బి పాస్డ్ యాజ్ ఎ పారామీటర్స్. ఎక్స్ట్రైన్ ఈక్వల్స్ టు encoder dot fit transform for the text to extrain. xtest equals to fill transform. Just I am doing the transform for the text data, whereas train data I am fitting and training the transform data. So this is the mix, and output is will be considered as mix. Data is converted into zeros and ones. So this is a shape and this is a shape. Shape of this, shape of this. So expand widen columns equals to. Now we are going to do the robust scalar. So robust scalar is a one type of normalization tool which is convert the data from zeros to one in the between of zeros to one. Normalization purpose we use this robot scalar. Okay. From scalar dot pre-processing import robot scalar like a standard scalar, right? Standard scalar, minimax scalar, that type of function only the robot scalar also. Chapale, right? Same alane undi. Okay, robot scalar anta. So that it will convert the data between the zeros and ones. Okay, x time equals to scalar dot fit transform and transfer. So PD dot data and test data. So this is the end of the data. And so see 0, 1, 0, 1. Okay, data is converted. Now I am going to apply the algorithm Navive classified. So from scalar dot Navive import Gaussian Navive. Gaussian Navive is the name of a algorithm. Gaussian Navive. So GNV equals to Gaussian Navive. I am initializing the model. And in that model, GNV dot fit extend widen, it's common. Extend widen I need to pass, and I'm going to predict the values based on the extend. Y predict equals to GNV dot predict extend. Let's go extend. Okay, this is the output. This is the output. So if you want to find the accuracy, it's around 81%. 81%. Understand? 81%. Clear? Like this algorithm goes. So if you want to find the confusion matrix also, you can find true positive is around this much, true negative is this much, true whatever. So these are the confusion matrix. So if you want to visualize the heat map, this is a heat map. Same things I taken. C maps is equal to data frame, CM, and true positive, true negative, and this is the heat map. Heat map, and this one is the classification report. So finding the accuracy, precision, recall, reference code. Clear? This is all about your Navive algorithm. ఏం సార్ వచ్చినప్పుడు నుంచి ఇంగ్లీష్లో చెప్తాను ఇంకా మీకు అర్థమవుతుందా లేదా టెస్ట్ చేద్దాము ఇంగ్లీష్ నిజాను చిన్నగా చెప్తున్నాను ఇంగ్లీష్లో ఫాస్ట్ ఏమని చెప్పేసి చిన్నగా చెప్తున్నాను ఒక్కో వర్డ్ ఆగిచ్చి చెప్తున్నాను దిస్ ఈజ్ ఆల్గడ్డం అబౌట్ Navive algorithm. From today onwards, complete I will teach in English. Both Telugu kuda mix chestam, mostly in English. Okay, this is the concept about the Navive. Endu sir English ante professionally. I'm also thinking I need to improve more about English pretty good. Okay, if you face any doubts, I will explain in the video. Like okay, so this is the complete algorithm.
Hello sir.
Hello,
Vijay sir.
చెప్పు విజయ్.
సార్ ఇప్పుడు మా విజువలైజేషన్ లాస్ట్ పెడతాను మధ్యలో కదా సార్ పెట్టేసినా కానీ
విజయ్ అది విజువలైజేషన్ అవుట్పుట్స్ ని చూపించాను విజయ్, ఎక్కడైనా చూపించచ్చు విజువలైజేషన్.
అదే సార్ మరి లాస్ట్ పెట్టింది కాబట్టి మధ్యలో పెడతాం కదా ఎప్పుడైనా కానీ అది డౌట్ వచ్చింది.
ఓకే ఓకే ఫైన్, మనం ఎక్కడైనా విజువలైజేషన్స్ అనేది మనం ఎక్కడైనా చూపించుకోవచ్చు, నో వరీస్.
ఈ పర్టికులర్ దీనికోసం ఓన్లీ బ్యాక్ ఒక లాస్ట్ అక్యురసీ మాత్రం చూపెట్టాలని విజువలైజేషన్ అని ఇట్లా చూపెట్టుకోవచ్చు అని ఇట్లా అనుకుంటున్నా.
నేను ముందునే చెప్పాను కదా విజయ్, నేను మధ్యలో జస్ట్ డేటా అనాలిసిస్ ఒకటే చేస్తాను, రిమైనింగ్ థింగ్స్ అని మీరు చేయాలి అని చెప్పి. సో మధ్యలో నేను విజువలైజేషన్ చూపించలేదు, అవుట్పుట్స్ కూడా ఎలా విజువలైజేషన్ చేయొచ్చు అని చెప్పి చూపించడానికి చూపించాను. నేను అప్పుడే చెప్పాను ఒక ఫార్మాట్ ఫాలో అవ్వను, మల్టిపుల్ ఫార్మాట్స్ నేను ఫాలో అవుతాను. సో అందులో ఇది ఒక ఫార్మాట్. ఓకేనా విజయ్? Say. We task early. Say. Algorithm. ఇదే డిపెండెంట్ ఇండిపెండెంట్ గురించి చెప్పాను. ఇక్కడ నుంచి ఉన్నావు డిపెండెంట్ వేరియబుల్స్. క్లియర్? దిస్ ఈస్ ద algorithm of average. Yeah. Super है. अच्छा है. अच्छा. अच्छा है. बहुत अच्छा. So this is all about the topic. So tomorrow I will discuss about the KNN algorithm. I'm planning to do live projects. Live implementation of KNN algorithm. If it is possible, I will do. Otherwise, I will show like this. Done? Clear? Clear? That's it. So that's it, guys. That's it from my side. If you don't have any doubts, you can leave me class. Thank you.